Hey, so we're going to look at the last way to solve systems of equations, and this one is by the elimination or addition method. It's called, well, both, depending on what text you read. Basically, the idea behind it is, again, we're trying to find the one x and the one y that will work for both of our equations. So we're trying to get our x and our y to be the exact same. Since we're looking for where the x and the y are both the exact same, I can assume they're the same and go ahead and try to add my two equations to eliminate one of my variables, hence why it's called both things. So if I look at my first example here, what would happen if I add them right away? If I add these right away, my y's are going to cancel because I have a minus 2y and a plus 2y. So if I add these, I have 3x plus 5x should give me 8x minus 2y plus 2y should cancel. Going to equal 7 plus 1 should give me 8. Now I have a super easy equation. Just divide both sides by 8 and I get x equals 1. Try to find my other variable. I'm never done until I have both variables. So I can sub it into either of my original two equations. I'm just going to choose my first one. 3 times 1 minus 2y equals 7. So 3 minus 2y equals 7. Subtract 3 from both sides. Negative 2y equals 4. So y should equal negative 2. So I have the point 1 comma negative 2. Okay, so I should check it just to make sure. So I'm going to sub it into my second one. 5 times 1 plus 2 times negative 2. Does that equal 1? And yes, it does. 5 minus 4 does equal 1. So this is the correct answer. Okay, so let's look at the second one. 2x plus 6y equals 6, and 3x plus 2y equals 9. So if I start this off, if I add them right away, nothing's going to cancel. I'd have 5x plus 8y equals 15, which doesn't help me. It just gives me more equations with x's and y's. So I'm going to go back to my previous example. The reason those 2y and negative 2y canceled is because I had the exact same number in front of them and opposite signs. Since I had the same number and opposite signs, when I added them, they canceled out to 0. So I want to see if I can get the same number and opposite signs in front of one of my variables. So I'm going to choose my y's again, and I'm going to say, okay, I'm working with equations. I know I can do anything to an equation as long as I do it to both sides. So I'm going to play with multiplication and see if I can multiply any of these equations by something so I can get the same number in front of it. So it's the same idea as when you're looking for a common denominator. So if I multiply that bottom equation by 3, then I'm going to get the same number in front of the y's. Top equation I'm not even going to have to change. I also have to get opposite signs though. So instead of just multiplying it by 3, I'm going to multiply it by negative 3. So let's see that top equation again. I'm not going to change. 2x plus 6y equals 6. That bottom equation, I'm going to get negative 9x minus 6y equals negative 27. Okay, so now I do have same number, opposite signs, so I'm going to add them. Positive 2x minus 9x should be negative 7x. Y should cancel. Positive 6 and negative 27 should give me a negative 21. Divide both sides by negative 7, I should get x equals 3. Again, I'm not done until I find both variables, so I'm going to sub it into either one. So 2 times 3 plus 6y, I'll sub it into the first, equals 6. So 6 plus 6y equals 6. 6y equals 0. And y equals 0. So I have an answer, 3, 0. I want to check it by plugging it into the second. 3 times 3 plus 2 times 0. Does that equal 9? Yes. So this is the correct answer. Okay, let's try the next one. 4x minus 3y equals 14. 3x plus 2y equals 19. I don't have to continue trying to eliminate the y's, but since these are already opposite signs, I might as well continue trying to eliminate the y's. So let's see, I want to get the exact same number in front of them and opposite signs. Opposite signs are done, so I need to multiply these equations by something so I can get the same number. Again, kind of like trying to find a common denominator. What is the number that 3 and 2 both divide evenly into? Both divide evenly into 6, so I'm going to multiply the top one by 2 and the bottom one by 3, so that way I can get 6. So on the top, I'll get 8x minus 6y equals 14 times 2 should be 28. 9x plus 6y. 19 times 3, 27, 57. Okay, so I do have opposite signs, same number, so they will cancel out. So I have 17x equals 85. So now all I need to do is divide by the 17. See if it goes into it. 85 divided by 17, let's see. I'm going to guess 5. So, yeah, that's going to work. So x should equal 5. So if x equals 5, again, I'm not done until I find both parts. I'll sub it into the first. 4 times 5 minus 3y equals 14. So 20 minus 3y equals 14. So minus 3y equals minus 6. Y is going to equal minus 2. So the point 5 comma negative 2. And again, you should check. Okay, let's look at the last one. 3x plus 6y equals 1. 6x plus 12y equals 2. I'm going to try and eliminate my x's this time. So I need to get the same number, opposite signs. So I'm just going to need to multiply the top one by minus 2. So if I do that, I'll get minus 6x minus 12y equals minus 2. The bottom, or the second equation, I already had. I didn't have to change it at all. So 6x plus 12y equals 2. If I add them together, my x's are going to cancel. That's lovely. But this time my y's cancel, which is weird. So I get 0 equals, and my other side cancels, my constants cancel. So I get 0 equals 0. Well, we already saw what happens when you get a false statement. So this time we got a true statement. True statement does not give you no solution. True statement gives you all real solutions. What a true statement means, such as 0 equals 0, is that I'm actually looking at the same line. So if I was going to graph this, it would graph to be one line directly over top of the other. So therefore they have every single solution in common. Every point that works for one line works for the other. And if I go back to my original equations, they are the same line. Really, only difference is that second equation was multiplied through by 2. But they are the exact same line. So they have every solution in common. Okay, we'll look at how to use this with 3 equations next.